Hello my dear friends, in this class we will see about some applications of our Michelson interferometer. By using Michelson interferometer, what type of ideas you can get, what type of values you can calculate, that thing we will see here. My dear friends, we are using light source. That may be monochromatic, that may be extended, that may be a single line. But a light source we are using. And as you are using a light source, we should be aware about of the wavelength of the light. Whatever light we are using, the wavelength of the light we should know. Then how we can calculate the wavelength of that light? That previously I have also told some experiments. By that we can calculate the wavelength. And this one means using Michelson interferometer also we can use the wavelength of the light source. Let's have a look on that. In the first application we will discuss about calculation of our wavelength of the light source. Okay, how we will calculate our wavelength of the light source. Now one more time I will make you remember the experiment, the Michelson experiment. What I did in that experiment, I took a light source, that is extended one, then I kept one convex lens, a 45-degree angle mirror, one more compensating angle. This is also called beam splitter. It will split the beam, means one part will reflect, one part will transmit it. Then one mirror was there. This two part was coming back here and we are observing something here, means this is our eyepiece. Then what I told, on the basis of this one, I drew one more figure explaining about the formation of the fringes, how the fringes are being formed. What I did there, I told that roughly I am doing this. This is my mirror M1, means this mirror, and this is my mirror M2 dash. This is the mirror of this M2. M2, due to reflection here, will form an image here, and I named it as M2 dash. These two, and my eyepiece here. Your source is here. The light is coming from the source and reflecting towards our eyepiece. The same thing, this light will go this way and it will reflect again. I had extended this one. So here one more. So what I did, this is the path difference I had calculated in the last class. Okay, in the last class what I told, due to this parallel line, you are watching these two lines are parallel. Because this M1 and M2 dash are parallel. These two are parallel. That's why the lines are coming as parallel. If I will adjust these two mirror in such a way, screws are there. Instead of this parallel, they will make a certain angle with each other. In that case, we can't get such type of a parallel line. Otherwise, it will intersect each other like this. In case of tilted manner, suppose this M1 is like this and your M2 dash is like this, whatever be. In the last class, I also did one more thing by considering, this is the last class things I am making you remember, and here I calculated my fringes. That means on M2 dash, I was calculating my fringe, whatever fringe formed by Michelson interferometer. So what I got such type of circular fringe. I have also calculated the radius of the circular fringe, whatever with the radius. So let's see. As I told, I am getting such type of fringes, and whether the curved part will align to what side, that depends upon the tilt, how the two mirrors are tilted. If these two mirrors are like this, then the fringes will be like that. Means the curved surface will be towards the junction of the two mirrors. In this case, means this case, these two are parallel. That's why such type of fringes I will get. Now what I will do, whatever I am experiment doing here, that same thing I am observing by the eyepiece. My dear student, go to the YouTube and see how your spectrometer is working. There you will see an eyepiece, and while you are watching inside the eyepiece, a cross wire will be there. wherever the cross, where you might have seen, suppose a army man is shooting a Maowadi or something, whatever he's shooting, he will put that cross section on the Maowadi or the criminal, and after that he will shoot, right? This type of symbol. Like the same thing, inside the eyepiece we have this type of a symbol, and this indicates us that we have focused on the thing whatever we want. Now I will focus my eyepiece here, means this is one line, this is one line of the intersection. How I will do it? I have to adjust my M1 and M2 dash in such a way the cross section of the eyepiece will fall on the central fringe. As this is fall on the central fringe, your theta will be 0. Of course it will be 0 because this is going through the normal. So my path reference formula was 2e cos theta. So it will be now 2e because cos 0 is 1. 2e, the center one, we know the center one is the bright fringe. Bright fringe means the path difference will be m lambda. So my path difference will be n lambda. That means my 2e equal to m lambda. Suppose now I will adjust one more time my m2, m2 dash. How I will adjust? By adjusting these two. Here I erased. By adjusting these two, I will adjust these two in such a way I will go to the just next bright fringe. Here the central bright fringe is there, and this is the next bright fringe. So after going here, I will see how much path I covered. So I will take it as the distance e dash. So my 2 e dash will be, as this is the next fringe, that is m plus 1th order fringe. Let's do some subtraction. That means my 2 e dash minus 2e equal to m plus 1 lambda minus m lambda. This m lambda get cancelled. So what left? This lambda will be multiplied with 1. So only it will give to 1 lambda. So your e dash minus e will be lambda by 2. Remember this one? We will use this one in a case. Now we'll see what will I saw that this is a path of lambda by 2. Till now I don't know how much the lambda is. Now I will calculate how much the lambda is experimentally. What I will do now? I kept my cross section here. This is the cross section of our eyepiece. I told like a gun. So your eyepiece cross section will be there. I will name it as x1. Okay. Now after that I will pass some fringes. Fringes 1, 2, 3, 4, 5. Suppose I crossed 5 fringes, and after that I put my cross section here, and this is your x2. This is x1, this is x2, and I told I have crossed n number of fringes. While I was crossing one fringe, how much path difference I was getting? Lambda by 2. When I will cross n number of fringe, how much path difference I will get? N into lambda by 2, with a distance from x1 to x2. So your x2 minus x1 will be your n into lambda by 2. So these two will be multiplied here. Your lambda will be, I should write it properly because this is the last expression. Lambda equal to 2 into x2 minus x1 whole divided by n. This is the formula to calculate the wavelength of the light source. Means this extended source I have used, and using this type of method I can calculate the wavelength of the light source. See, this is unknown to me. This n is known to me. How? Here I told I crossed 5 fringes. So whenever you will be traveling your spectrometer, you will be searching, you will be numbering how many fringes you are passing. 1, 2, 3 like that you have to count. This is in random, I have considered n. So this is known to you. x2, x1, in the eyepiece you will have a scale. Suppose x2 is giving you 2, scale 2, and this is 5. 5 minus 2, that is 3 millimeter, whatever unit will be there. So all are known, only lambda is unknown. From these things we can calculate easily what is the wavelength. And one more thing, This is also very accurately you can found, because the accuracy factor is something like 10 to the power minus 4 millimeter in case of spectrometer. Okay, this much is about how we are calculating the wavelength of a light source. And please go through this. Any doubt, if you have any doubt, then please give in my comment, or you can text me, whatever be. Thank you so much.